We're going to talk. Okay. So if you, so this part has been done on the lathe, and if you look at this part, the part looks like something like it's a part for the milling machine. So yes, we can do this on the mill. That's not a problem. But again, we can do this also on the lathe with the live tooling. If you have live tooling, C-axis, called C-axis live tooling. So what we can do, we can turn the round stock diameter, we can turn that like this here first into 2 steps, and then we can mill this with the C-axis. We can mill this outside, we can mill this rectangle outside. This rectangle, we can mill that outside with the C-axis. Then we can mill this flower shape, your star inside, and then we can drill this on the face also. So that's called, we whatever we have done on the last 7-8 projects, guys, we have done the lathe part with the standard lathe operations, which is facing, OD turning, OD rough and finish, OD grooving, and OD thread, ID grooving, ID thread. So that was a regular, simple, standard operations on the lathe. But now we are moving into a different environment. Still, we're going to work on the lathe, but this lathe is equipped with live tooling. When we say live tooling, means you have what's live tooling is. Live tooling is uh, fixtures will set up on the machine, and that can mill the outside, and that can also drill the face, and it can also drill the diameter. So hold on one second. I'm going to stop sharing here. Let me get a little video here. I'll show you that how this live tooling works. So hold on one second. I'm going to stop sharing. And I'll be right back with you guys. Just bear with me. Guys, you can see my screen.
Yes, sir.
Okay, you see this the lathe spindle, right?
Yes, sir.
Okay.
Yes, sir.
Okay, so here I'm going to show you this video so you guys can see what's the live tooling is. So I'm going to go ahead and run this, and then I'm going to stop and play and stop and play, and we're going to go over this. So here is that. So what that tool is doing, that tool is facing the part like a regular operation we talked about. This is my stock here, and it's a Teflon. The material is a Teflon, so we can have aluminum, steel, doesn't matter. So it's just facing the part here. And now the next tool, look at the next tool. That's a drill. So that drill is called face drill. It's drilling off center on the face. So these are live tooling. The one you see here and see over here, guys, these are your live tooling, and this is a fixture right here. These fixtures, you can take it out anytime you don't need it, and you can put it here. If you look at those screws over here, can you see my cursor, guys, on the screen?
Yes, sir.
Yes, sir.
Okay, so look at that. These are the screws right here. These are the screws. So you unscrew this, and you can take this fixture off, the live tooling. You can take it off. Same thing over here. You can take those off. So these are called the two type of live tooling. It's called axial drilling, and it's called, this is going to be your axial, and the other one is called your radial. So the axial is parallel to your z-axis, and you can drill on the face off center, and the radial is, it can cut on the diameter. So this is also axial, this is also axial. So these are your live tooling. With live tooling, your spindle is turned into c-axis. So this axis becomes your c-axis. You have x-axis, the one we already talked about, and you have z-axis. Those are two standard axes. Now, when we talk about the third axis, that becomes your c-axis. This is a c-axis. The spindle is going to turn. It's not going to spin like 2,000, 3,000 RPM, but it's going to start sync with your x-axis and z-axis, and it can mill the outside. You can drill the front, you can drill on the diameter. So axial drills on the face, radial drills on the diameter. So I'm going to show you that video, and then we're going to keep going, and we're going to talk more about that. So here we go. Let's continue. It's drilling on the face. Look at it, off center. Your regular standard lathe, you cannot drill off center. You can only drill in the center. Drilling off center on the face, you can only do if your machine has a c-axis capability. So here we go. Drill those two holes. Now look at this. There's another drill, and it's just look at the punch milling the hole. That's a c-axis. That's a combination. And your spindle is not turning. This is the live tooling right here. It's called live tooling. And here comes the reamer. You ream that hole, it's going to come out. It's going to ream that hole. Okay, here's your live tooling. It's still your axial. It has a, I think, half an inch end mill, and that end mill is going to mill outside. It's going to mill outside. Watch here. And see that now? Now, if you look at that, how slowly the spindle is moving. So that spindle becomes C-axis now. It rotates in degrees, anywhere from 1, 2.1 to 2, 3 degrees up to 360 degrees. So that C-axis sync with your X-axis, and it can create any type of shape. It's working just like your mill machine, guys, just like your mill machine. You can assume that this is your part on the mill machine, and this is your Z-axis, your spindle, and it's cutting around the part. Look at that. Look at this, how slowly the C-axis is moving. It syncs with your X-axis. That's the C-axis here. This is your live tooling. Here. Now, this tool is your live tooling. That's called your radial axis. Radial means it's gonna cut, can cut on the diameter. It can drill and it can cut as your key slot, and it can cut or any helical around the part with this fixture, with this tool. So this is called your radial live tooling. And you can have, this is your collar, just like your milling machine. You have a collar, you can put any tool. You can put center drill, you can put tab, you can put end mill. So the other one, the one we used earlier, can work on the face, is called your axial, because your axial is parallel to your z-axis, your radial is parallel to your x-axis. So this is my radial live tooling right here.
I have a question. Some machines have a y-axis. Is there any difference between c-axis and y-axis, or they are the same?
Things like that. Here's a parting tool. It's cutting it off. There it is, and there is your finished part. And now, if you look at this part, that part is actually a good example to do it on the milling machine. But we have, if we have an option, we have a capability on our lathe to have a C axis, which have a live tooling radial and axial. Yes, we can do milling and turning both on the lathe machine. Let me go ahead and see another example over here, guys. Um, okay, there's another part right here. Let's look at this guy. Okay. Look at this part. Is that's your axial drilling and it's milling. We have done OD regular standard operation. We faced it, OD to rough and finish it. Now we are milling the outside with the live tooling. Look at that. So now your spindle is working as a C-axis. When we call the spindle speed 2000, 3000 RPM, that spindle speed is for your live tooling, not for this main spindle. That spindle speed is for live tooling. But this is working as a combination of your x-axis with this your live tooling, and your spindle becomes your main spindle becomes your C-axis. I'll show you the program when we go there. Now on this part here, guys, on this part, your center of the part is your x-axis, your z-axis, and this is your x-axis. Your center is still your x0, your z0. But to cut this shape right here, the shape you see, the how your tool is cutting the rectangle over here, this is the geometry we have to create in construction plane right. So this is your Z0 from the face of the part. Your tool is going whatever the distance is going to be Z minus 1 inch. So we're gonna control that Z depth in our parameters. But we have to create this shape of this piece, the work piece, the shape we have to create in construction plane right. And then it works just like your mill, like the way you guys did in 173 2D Mastercam class, guys. It just worked like a mill. There's no difference. Once you're going to get into the program, you're going to see all the parameters in the toolpath. It's going to be just like your mill. You can face contour outside, number of passes you can control, the depth, how deep you want to cut each time. You can all control that too. But this shape of the joint, we have to create it. Let's see if we have anything else. Okay, here we go. Look at this. That's your live tool. This here is your radial. This is your radial. This was your axial. Look at the radial is cutting on that. Diameter is drilling the holes on the diameter. But this shape, the geometry of the part, we have to create the geometry of the part in our construction plane right. Look at that, the tool is turning it, and it's milling outside. That's your radial, it's cutting outside diameter, drilling the holes on the diameter. Look at that. Let's see if we have any other good example I can show you guys. So you can watch those videos on YouTube under live tooling, you guys. Okay, look at this part right here. We're going to turn this. This is, it's going to face it and turn. It's drilling. So now when this tool is drilling, the spindle is turning because the drilling is right on the center. Here's your live tooling. It's cutting the outside. And look at this, how slowly your spindle is turning because it turns into your C axis. Okay, this is your radial. Parallel to your x-axis is your radial. It's cutting diameter. When you run this kind of part, guys, with the live tooling, you have to always be careful what is your size of this fixture right here. If you look at here, we are milling or drilling right here on the diameter, but the tool fixture is right here. It's very close to the spindle. So you have to know that what would be my thickness, where the center of the tool is, that how far I can cut from the face into the part, my Z minus, so that your fixture can't hit the jaws back over here. Look at that. All right, so here we go. I'm going to just go ahead and turn that off. And look at this part right here, the part, the one we're going to do. So it's the same thing. It's the same thing. We're going to create this geometry first, just for your regular if you look at this geometry, guys, this geometry has to be something like this. We're going to create a diameter of the part like this first. And this is going to be my center line. This is my zero over here, right on zero. So I'm going to create this. I'm going to face this part, then I'm going to turn the diameter and this diameter. Then we're going to create this geometry right here on the right side plane. And then we're going to use the live C-axis tooling and create this contour right here. And then we can face drill that. And we can drill this right in the center. That's going to be our regular drill. So I already have a part. Let me show you, and then we can go over this part. So just bear with me. Let me bring that program right here. If you look at this part right here, this is, I'm looking at the top view. So in the top view, under level 1, I'm going to turn that off. So on top view, I have created this diameter and this diameter. This diameter is, this is my hole. This is my center line here. So this is my hole. I'm going to drill this hole right here. That's where I'm going to drill, and I'm going to bore it. And this is going to be my diameter. I'm going to turn my to this diameter, which is going to be a little over than this diameter right here. If you see, this is my square, 1.475. So my stock size is not going to be 1.475. This is going to be stock size. I put my stock size a little bit around maybe 2 inches. That's going to be my stock size right here. And then I'm going to mill this square. I'm going to turn this to the certain diameter, and then I'm going to mill this square. Then I'm going to mill this star over here. So then I can face drill this like 1, 2, 3, 4, 5, 6, 8 holes. Then I'm going to face drill these 8 holes. So I have this program here. Let me show you. So what we do, the first, we have to do 2 different geometry. The first geometry we're going to create, which is this guy right here, and that's going to be standard geometry like we did earlier. So I'm going to just go ahead. And run this part right here. So what we do regular, facing, and turning. Watch here. Here. We are just turning it. I skipped facing, did I? Yes, I skipped facing. So here's a face and OD rough. And OD finish. And then I'm going to get a drill. I'm going to drill right on the center. There we go. That's my drill. Then I'm going to just go ahead and also I'm going to bore it. So I got lathe rough and lathe finish. Look at this. So if you run this part, it's facing, turning, OD rough, OD finish, and drill, and it's going to bore this. So this hole is drill, and here comes my boring bar. I'm going to rough it, and then I can finish it. Here comes my finished boring bar. It's going to finish the hole. So this is standard operations we do first. So let me go ahead and verify this. I'll show you guys. So look at that. This is my regular process, the way we used to set up the diameter, and this is my stock size, and I'm going to just go ahead and face it. And then I'll just go ahead and turn this to that diameter, and then I am going to finish it, and then we're going to drill it, and then we're going to bore it. Bore rough and bore finish. So that's what we do. So if you look at the part, this is what I did. I finished the hole and I have my start, which is going to be a little over whatever this is. You have to be a little over than start size. We got this. Now we're going to just do the live tooling. Now we're going to do the live tooling on that. What is live tooling? No, sorry. What is live tooling now? Now, so this is going to be our base geometry. We have to turn this face and turn the diameter to the size we wanted, and then we can do apply C-axis live tooling on that. So if I go to under toolpath, guys, if you remember, this is what we've been doing last 2-3 weeks. This is what we are using. We are facing it. We do rough and finish, then we drill it, then we have a groove, and then we have tap and lathe. But this is your C-axis over here. This is your C-axis work as your live tooling. C-axis face contour, C-axis contour, cross contour, face drill, if I'm going to drill this on the face. So to do that, now what we do, if you go to the levels, and we have to create a geometry on the construction plane right. If I'm going to go to level, I'm going to turn my geometry level 2. Look at this is my geometry. If I will go to construction plane right, this is my geometry. I have to create that. Just like my part. This geometry right here. First I have created this part right here on the top plane. I face it, I turn this to this diameter, and now I have to create this. Now based on your blueprint, if I'm going to cut this star here, the depth of the star is going to be only 130,000 from Z0. And then the total depth is going to be 130,000 plus 259. That's going to be 389 total Z depth. To cut this square back here, the depth of the square is going to be 389. Then we're going to drill the holes and on the face. So basically you have to draw this drawing here on the construction plane right, which you see over here. Look at that part. The one you see in the red, guys, that geometry is on the top plane. If you remember, we use this just to face and turn. That geometry is on the top plane, which we use these functions right here: lathe finish, lathe rough, lathe finish, lathe drill, lathe rough and finish again. So that is going to be your turning this off. That geometry, we have to work on this geometry first. Then we go and turn that off. We can go and work with our right side plane right here. So on the right side plane, if you look at here from Z0, the top of the part, I'm going to go to construction plane right. So here is my Z0 on the top, on the right plane. From here, this is my depth. So you can create this at a certain depth if you want to, or you can create everything at Z0. And then we can go for the toolpath. Now, if you look at the C-axis toolpath, they are right here. C-axis face contour. Look at that, comes your C-axis, your live tooling. This live tooling is going to cut this square right here. Watch here, look at this. There comes your live tooling. Now it's cutting a square outside. That's your live tooling, what we have just seen in our video on YouTube. If you look from the top view, look at this, guys. Just work like a mill machine, just like a mill. 173 class is cutting. You pick up the geometry, it's going to cut around the part. It finished that. Now if you look at the next tool here, C-axis face contour, it will cut that star. Look at that. It will cut that star just like mill. But here, the geometry we're going to create not on the top view, we're going to create on the right side view. There we go. And then we're going to drill this face drill again, just like your mill. It's going to come and drill this just like a mill, guys. Look at this here, just like mill. Don't get confused. It's not tough, and you're maintaining the same depth, Z minus, from the top. That's my Z0. If you look at the mill, this was my 0, and I'm going from here Z up and Z minus. Look at that. But the way it works like this. It works in the front plane, on the right side plane. So if I'll run this entire part, you can see how this works, guys. The first is going to be on your regular lathe part, and finish. So look at this here. I'll face it, and then I turn it. So this diameter, the one we created over here, guys, that has to be more than the diameter or the size of your rectangle we have. So I picked up about 2 inches or 2.1. You can make it a little bigger. That's not a problem. And then we cut on that. So here comes my drill. It's going to drill that. There's my boring bar, rough and finish. And here comes my live tooling. Look at that. This is going to cut that geometry right here, the one in green, the rectangle. Here. And if you look at here, that follows that geometry just like mill, guys. Look at that, just like mill. This is my Z0, and I can maintain my depth from here going down Z minus. If you look at this part right here, the Z minus from here to here, look at the blueprint, it's right here, 130,000. This depth is 130,000, and that's what you see here. From here, it cut this star 130,000, and depth from here to here for the rectangle, we went a little more deeper because we're going to cut it off. The depth from the top to this rectangle is, the depth is right here, which is 239 plus 139, that's your 389. But we went a little bit over 389, we went 400 something, so we can cut it off. So but that is your depth right here, just like your milling machine, guys. But the way it works on the lathe, if you look at isometric view, that we control from the face, that's my Z0. From here to here is my depth of the star. From the Z0, this is going to be my depth of my rectangle. And now I'm drilling that face. That's your C-axis face drill. And here comes my parting tool. It's going to cut it off. Look at that. And that is my finished part right there. That's my finished part. Just like your mill, guys. There's no difference. There's no difference. All right. So this is what we're going to do on this part. And like I said, this is going to be tool path. So we're going to go ahead and create that geometry on the top plane here first. And here, if you look at the blueprint, I think we went a little over that. Let me check that line. I think vertical, that line is, we went that line is at 380.89, this line right here, because this is 389. So we have drawn this line over here. If you look at that line is right here. 130 plus 259 is 389. So now you look at here, this is 389 from here to here. That axis offset is 389. My Z0, that's 389. So that's your total thickness. And this diameter right here, if I'll go ahead and draw that line horizontal from here, so that Y is 1.043. I can even do 1.1 or 1.050,000. So that is going to be my diameter. I'm gonna rough it. So we can draw this 1.1 or 1.050. That's okay. And then this is going to be my the drill, the hole size. If you look at here, this is the hole size right here. That's my hole size. So that's 648. So half of 648 is going to be 324. So this is going to be 324 right there. So this is 324. If I'm going to draw this line here, over here, horizontal line, if you put 348 over here, point 348, so that line is going to be 340. Oh, come on. 0.348. There we go. Is it 348 or did I do the math right? 324. Half of 648. 324. It should be 324.324. And look at that. That matches right there. Not this one. This 324. So based on this blueprint, we're going to just draw this guy here first, and we're going to face it, and we're going to go ahead and turn it. So this is how we're going to proceed. We don't need this line right here. We don't need this line back over here either. We just need this diameter, and that diameter is, I can go 1.050, and then I can have this here, which is going to be a 248, something like that. Okay, so let's and then under level 2, that's we go to the right plane, and we're going to create this on the right side plane. Look at that. That geometry has to be on the right plane over here. All right, so let's get the drawing. So I'm going to go to file. I'll go to a new file, and don't save it. Is it going to crash or what? Yeah, it did crash. Okay. So I will start with my level 1, and
Professor,
yes.
I don't think you're recording.
Oh, thank you. Yes, let's start recording. Thank you so much. Record. Thank you.
Recording in progress.
Okay, so we're going to go with levels, and level 1, that's what I'm going to create, and I'm going to construction plane top, and 2D, and I'm at Z0. So what I'm going to do, like I said, this diameter right here is, the finish is rectangle is 1.475 rectangle. I'll draw this about a little bit over 2 inches diameter. So I'm gonna go ahead and create wireframe, create a rectangle, and rectangle, I'm going to start from there to here. So here, so here my width is going to be minus, and I can go exactly this size, 259 plus 130, guys. That's going to be my total thickness. So that comes out 389. So I can put that, my width minus 0.389. There we go. And I have to change my, oh wait a minute, I cannot see. Let's do it again. Change that color to green. And I can go ahead and draw this rectangle again. From there, we are on construction plane top. Good. So width is minus 389. And my height is going to be a little bit over 2 inches. If you want to go 2 inches, I can go 2. I can go 1.05, half of that. So there comes my diameter. We can go 2 inches, which is going to half of that with 1 inch, but I think we should go a little bit more than that. I'll go 1.050. So this is going to be my diameter. I'm going to turn this to. And same thing with the width is 389. I can go up to minus half an inch, guys. So looking at the blueprint here is 389, but I'll go a little bit over that. Let's go even minus half an inch. So we can do that here, minus half an inch. We're going to turn this to that diameter, which is okay. So minus half is my width. My height is 1.05, and hit OK. And hit OK. So now Alt F1. So now I have a hole. I have to bore this, and this is 648. So the radius is going to be 324. So I'll go ahead and draw a line here, wireframe line horizontal, and that's going to be my line here, and this is going to be 0.348. 0.348. There we are. Let's double check that blueprint. Yeah, the hole is 648. Half of that is going to be 320, 324, and that's what we have. Okay, so okay, and we can go and divide. We don't need this here, and we don't need this here either. We don't need this line, and we don't need this line back here either. We can just go ahead and delete that line too. So this is going to be my face and OD rough and turn, and then I can go ahead and drill and bore that. So based on that, we can set up our job. But if you look at here, guys, my 0, that's my Z0, and we are on the top plane. But now I need to draw this picture right here. This geometry right here, a rectangle, and this star and those holes. So this, like the way we do it on Mastercam in our regular 2D mill class, we do the same thing, but here we're going to construct this in the right side plane. So here I can go ahead and hide this geometry under level 1. Now I can create a level 2, and under level 2 I can put this here, my geometry for the side geometry. You can name anything you want, side geometry. So that's going to be a level 2, and I can hide this guy here. Now let's turn this on. If you look at isometric view, this is your drawing, but now I can go ahead and I can go to construction plane right, And that's where we have to draw this. So this geometry we don't need to turn this geometry on. We can just go to level and turn that off, number one. So let's work on level 2 and geometry in the right hand. Guys, watch this here. I'm in construction plane right. And I'm going to create that geometry in construction plane right. So I'm at right. So if you look at this blueprint right here, the depth of this part, the total thickness of this part from the top in is total this one here. And the depth of this star is 130,000. If you look at here, this is 130,000. So you can draw the star at z minus 130,000, and you can draw this rectangle back here at z minus 389. Or you can draw everything at z0, and then you can maintain the depth in the parameters. So either or, doesn't matter. So what we can do, we can draw everything at z0, and we can maintain the depth. And on the other part, we can I'll show you that how you can do it on the different z depth. So let's try to do that. So I'm going to create a rectangle first. I'm going to create this rectangle of 1.475 at z0. Then I'm going to start creating this holes. Everything we're going to do it at z0 right now, and then we can move that further down. Okay, so 1.4575 rectangle at z0 in construction plane right. Keep that in mind. Okay, just like a mill, guys. Just think that we are working on a milling machine. The way we used to do the drawings in your 173 class, that's how we are doing right now. So I'm going to say rectangular shape, and it's going to be origin is right in the center. The width is 1.475, height is 1.475, and there is my rectangle right in the center. And I can put my radius, fillet radius. If you look at the blueprint, the fillets, we have round radius 30,000, 130,000 on each corners. So we can do that also. Put your radius 130, and we have radius 130,000. Apply, hit OK, and there's your drawing in the right side plane. If you look at isometric plane, that is my drawing right rectangle. Okay, go to right plane. Now I can go ahead and draw these holes right here, guys. If you look at that holes, this one here is 0.907, the center line. No, 1.136. That's going to be divided by 2 is going to be my x, and my y is 1.4, and where is x is 1.475. Oh, it's going to be the center of these two holes. Okay, with the center of the fillet, that's where the holes are going to be. X, where is my y dimensions? Right here. Are we missing something? Hold on one second. Let me pause the video here.
Recording stopped.
Uh, 1.136. That's your x on the whole. Where is my y-axis? The center of okay. I am blind or what? X is 0.737, okay. How about my Y? That 648 is that. 1.136, okay. We don't need that. 1.136. I'm assuming that holes are in that center. Okay, hold on 1 second. Let's try to then we'll come back and circle center point. Radius 0.130. Okay, what's the location of these holes, guys? Is something I'm missing it? Because if I want to draw these holes, X is right here. Where's my Y location? The 648 is for this.
I think the holes are located on the diagonal of the square. So if you just put the x-axis number and kind of like a cross section that x number with the diagonal of the square, it just, you know, the cross section is going to show the center of the holes. I'm not sure if you understood what I'm talking about.
But to draw this hole right here,
it's going to be 45 degrees from the center.
Yeah, but it should be, it's a 45 degree, but where it should be your Y and X. Like X is given, there should be a Y given over here from the center. This is missing right here. These dimensions are missing. I know what you're saying, but yeah, that's what we have to do, I guess. We have to draw 45-degree line and then X and pick up that center. Let's try that because I think this is not right. X's are given, but these holes is 733, okay. Then for these holes is 1.136, but where is your Y? The Y is not given.
If you draw a center point square, all of the corners will be the centers of each hole.
Say it again.
If you make a square and the center point is the middle of the square, each of the corners will be the center of each of the holes.
So you're saying that just draw that 1.136
as a square, yeah.
733 as a square, then that corner is going to be that. Yeah, there's a couple of different ways to do that, but I cannot believe that the Y is not given. Okay. If I can draw this, the center of that hole, no, that's not going to work. Okay, let's try this here then. Okay, so we have to draw a couple squares, so that's where we can drill and we can get rid of that. But this print is amazing. 733, no, that is not right. Strange. 1.475, that's right there. Okay, so let's do another rectangles, or we have a couple of different ways to do it, guys. We can draw a line from here at 45 degrees, and we can have an X over here wherever that intersect. We can draw the center point of that as a whole, so you can do that, but drawing a square is going to be a lot easier. So rectangle shape, and we can draw this from the center to here. No, radius is 0, and width is going to be, the outside hole is 1.136, and height is going to be 1.136, and the other one we can do it right, same thing from here. The width is going to be 0.733. The print is not right. Okay, so let's do that. I think that's the only way to do it. So we can draw those holes, and the radiuses are 130,000. 130,000. The small holes are same. We gotta turn this on. Forget to turn the
Recording in progress.
Okay. I'm gonna go ahead and delete that, do it again because it was not recorded, so you guys are gonna have problem doing it. So let's go ahead and do this again. So I'm gonna go to rectangle, shape, right from the center, and here comes my width, 1.136. Height is 1.136. Rectangle, and there's another one, smaller one, is going to be 0.733. No, yeah, 0.733 and 0.733. There you go. Apply, and there are radiuses, diameter 194, radius 133. Okay, so circle on these corners. That radius is 0.130, and I'm going to just go ahead and lock it so we can have there, right? Okay, unlock it, and the next one is diameter. I think that's same 133. Okay. Let's use the same way there. No, these doesn't look right. Are the small holes you guys see at a different radiuses or same? This doesn't look right. Oh, this blueprint is pretty messed up. A radius 130. I mean, those radius 130 is going to be for the fillets. So those are 194. If diameter 194. Let's try that. 0.194. Yes, that makes sense. 0.194. 194, and this is going to be 0.194, 0.194, 194, there and there. And let's delete this guy, this, and this, and delete them. Okay, that's better. So once we have done that, so yeah, so it's really hard to see it, guys. I don't see that. Okay, 194 diameter. So just draw these four holes, 194, and then we have a radius there, 130,000. Okay, so get rid of this. We don't need these lines anymore. And we're going to go create arc polar with this center point, and I'll go from there to there, and that radius is 130. That makes sense. I can just go ahead and transform mirror this guy here to y-axis, hit OK, pick this and this, mirror that to y-axis there. Right click, clear colors, wireframe. We can go fillets over here between this guy and this guy. The fillet radius, sorry, fillet entities, that radius is 656 fillets. We're going to put radius 0.656. There you go. Between this guy and this guy, and this is my fillet. This guy and this guy, that's my fillet. Oh, don't trim that. Between this and this, that's my fillet. This, that's my fillet. If you look at this dimensions right here, guys, don't worry about, hold on one second. Don't worry about this angle 103 degree, doesn't mean anything. Don't worry about this 907 dimension. Just create those holes with a diameter of 194, and with the same center point, just create this radius 130 arcs and create a 656 fillet. So just ignore this angle degree in between. You don't need to worry about that. And ignore this dimension also 907, which is a tangent point. I don't know why they gave this tangent point over here. They should have given, like we have this dimension, they should have a dimensions from here to here. And okay. It's the same dimension, guys. All right, there you go. So let's clean it up. We go to divide. And we can go ahead and trim two entities. Trim two entities. We're going to trim this guy and this guy. We're going to trim this and this. This and that. Trim this and this. This and that. And trim this and this. There we are. Okay. And there is a circle in the center. We don't need that, guys, because that center, the hole is going to be, or just for your information, you can just create that. Make sure you unlock it. That circle in the center. And that is 648 diameter. But we don't need this. Now here, if you want just for the holes, we can have a point right there, and I'm going to change the color for that. Right color. So we can have just a point right on the center. And it okay. So we can put this circles in a different level, and we can hide them. We can put this on level 3, and here you can name those face holes. And we can hide those because we just need the center point of the holes just when we're going to drill that holes. So you don't need to have a circle. So I'm going to just go and turn this back on, and my geometry is pretty complete right here. So, and same thing with circle. We don't need to worry about circle. You can also put the circles in the same level. Right click and put this on level 3 here. Okay, so you can turn level 3 off and can turn those off. So just to look at that, how your geometry comes out, you on, but for toolpath, we don't need that. We can just go ahead and turn that off, and we can pick this center point for the holes. The size of the holes is going to be size of the drill we'll be using. So we don't need that. Okay, now looking at isometric view. So this is my drawing right here. So I have drawn everything at Z0, but the depth of my square 1.475 square, this guy right here, this guy, if you look at the depth is 2.59 plus 130,000 from the face of the part is 389. You have two options. You can leave this as is, and when we're going to do the face contour, we can control that depth. We can control that depth in the parameters, or we can just go and transform this guy right here and translate that Z minus 0.389 back here. So when we're going to do the toolpath, we're going to pick this geometry, now this one here, and our depth is going to be an incremental, is going to be Z0. So I can move that if I want to. Or I can leave this as is. So we can program different both ways. So I'll just go ahead and do this. Redo. Okay. I think we changed the levels also. So yeah, face levels we changed to a different level. Let's redo it and redo it. Okay, that's good. Changing that. Okay. There you go. That's good. Okay. So now I am going to save this geometry and change that level, everything to level different, or I can just go ahead and save that geometry file, save as, browse under Lathe, this is our project number 9, I guess, right? I will save this as project 9-A, and now I am going to change the Z level, and we're going to program both ways. I'll show you the both ways how you guys can do that. Okay, so now we're going to go to transform and hold your shift key, translate, hold the shift key and selection, and I'm going to go Z minus, and that depth is going to be this here right there, 130 plus 259 is going to be 389. Z minus 0.389 here. So I move that back here, hit OK. Now this guy right here, hold the shift key down, click that, end selection, and I'm going to move that how deep. If you look at the depth is 130 for the star. I'm going to go change to 130. So go Z minus 0.130. I'm going to move that. Here we are. Hit OK. So this is, if you look from the front view, I have my Z0 over here, and this picture right here, what you see is right here. I have my face on the part, my star is 130,000 deep, and my rectangle or square 1475 is 389, and that's what you see right here. So we can program this way, or we can program at Z0 also. So let's go to construction plane right again, and there we are. So if you look, I'm going to turn this off and turn this off. This was my previous geometry on the top plane, guys. So I will go ahead and change the color of this. I'll change this to red color. There you go. So now if you look at all this geometry, you have this at different levels. So we have the top, and we have right side plane right here. So we're going to start setting up with our top plane, and we're going to turn these guys off. We're going to work with this, what we've been doing on the last project. So this is, I'm going to go ahead and face this. I'm going to set up my stock size based on this. I'm going to face it, I'm going to turn it, drill it, bore it. Then we're going to work on the right side plane. Okay, so let's go to machine. That's going to be my lathe default. Get on our stock setup, and I will make from 2 points. Come on, I don't need this. Let's make from 2 points, which is going to be this guy and this guy. So that's going to be my size 2.1 and 0.5. And I'm going to go and select my margins. So here my OD margins, I have 100,000 extra material, right margin I can leave 100,000 also. Back on the left margin I can leave 0.5. Review your boundaries, there it is. There it is. Okay. Okay. Let's go and look at your chuck size, jaws. I can do the parameters, outside diameter, clamping method with outside diameter from the start, grip on the maximum diameter, grip length. We can put point stock size. We gotta go a little bit more here on that. Change this to left margin 1 inch. There we go. Hit OK and go under jaws here, and I'm holding from stock, grip on the maximum, grip length 0.5. We are good. That looks good right there. Hit OK and hit OK. Start diameter, perfect. Okay, so now I'm doing my regular operation. This is not involved with the C-axis. We are just doing regular face, rough and finish, and then we can drill it and we can bore it. Okay, rough face, pick up our facing tool, which is going to be my 80 degrees, and we can use rough step over 0.050,000, and rest everything is same, guys. I'm going to just skip those, just going to face it, and then if it's finished, yeah, it pretty looks like it's finished the face. Yeah, that's good. So now I'm going to go ahead and OD rough. For OD rough, I'm going to just pick this single. I have only single entity right there. Perfect. That's it. And hit OK. Hit OK. And I can use just 80 degree, or I can just use a 55 degree one. Doesn't matter. Okay, let's use 80 degrees, and there we go. My lead in, lead out. Lead out. I can extend that another 100,000, and I can go straight up. My lead out. Hit OK, and there is my stock. And make sure you pick that. Use stock for outer boundary. And there is going to be my rough and finish. So there comes my finish pass. Now I'm going to go ahead and finish it. Use your last chain. Hit OK. And I can use my 55 degree tool holders. Lead in, lead out. Lead in is OK. Lead out, I'm going to extend that also 100,000. And my vector is going to be 90 degrees. Hit OK. There you go. So if you're going to select all and see what we did, face it, rough, and finish. There we go. I'm going to cut it off here, guys. I can go another 100,000 into that. So what we do, we can go under parameter, under lead in and lead out. I can go 200,000 here, because I'm going to cut it off this part. So it should be okay if I'll go another 200. So hit OK. And now I can go here with the finish to, same thing, lead out, go 200,000. And we are good. There we go. So here we have extra material where I can cut it off, that part right there. Our finished part is going to be up to here, 389. So we're going another 200,000 extra. That's good. Okay, so now let's drill it and bore it. So 648 is 648, hole size is 648 finish. So I can use 1/2 inch drill it, and then or 5/8 drill, and then bore it. We can go use center drill, end drill if you want to. I'm going to just skip that. We can just go ahead and use a regular drill. Select all, turn that, and there comes my drill. Okay, we're going to use spot drill. We can use spot drill. Depth, let's say minus 0.200, and clearance 200, drill point is x0, z0. We are good. Retract 200,000. That's good. So there we are. And now go ahead and drill another drill, which is going to be my. This is 1/2 inch drill. We don't have 5/8. We can change this and look for 5/8 drill. Just use 1/2 inch drill. The depth is, we can go a little more than that, minus 0.500 depth. That's okay. There you go. You know what? I can go more than that. I can add a tip if I want to. 150,000, that's good. And perfect. And now we can rough and finish the bore. So there comes my rough. Pick single, just this entity. That's what we're going to do it. And I'm going to use my tool holder rough. 750, 250. We have 3/8 somewhere. We can use 3/8. I don't have that. We can use 250 right there. That's okay. And we can rough it out. Lead in, lead out is very important. Lead in going straight, lead out is coming at minus 90 degrees, and we should say plunge is okay. And use stock for outer boundary, that's good. And there is my rough. Okay, we can go ahead and finish it. Finish. Same tool, single. And chain, hit OK. And use the same tool holder. Lead in straight in, lead out straight minus 90 degree, hit OK. And hit OK. There you go. So select all. And let's run this part and see what we have. Face it, turn, finish, drill, drill, and bore. There we go. Perfect. All right, so we're done with this operation, guys. So these are going to be regular standard lathe operations, what we've been doing. Now here comes your C-axis. Rest of the stuff, if I'm going to go to level, and I can go and turn these on, and make sure you turn that off, because this is going to be on your way otherwise. Just turn that off. We don't need that anymore. Turn this drawing off. You just go to site geometry and turn that off. There we go. We don't need that. Go to construction plane right. And now we're going to work on this area. Here comes all my C-axis stuff. That's where we're going to go ahead and contour on this guy, and drill the hole. I don't need to see the circles either, guys. I can just go to level, and I can turn the face holes off also. All I need the point for the center of the hole to drill the holes on the face. So this is what now we're going to work on. I'm going to pause here.
Recording stopped.
And I'll be back. Let's take a little break over here, guys. I'm going to go ahead and get my drink. And I'll see you guys maybe in 5 minutes.
Recording in progress.
Okay. So now we're going to go ahead, looking at the right plane, and we're going to machine this outside, and we're going to machine this outside. Then we're going to do the face drilling. So this is going to be your C-axis tool path. And like I mentioned, that not all the machines have a C-axis capability. Your standard lathe have only two axes, X and Z axis. The machine has a C-axis and Y-axis, can only create this kind of program, which is called your turning and milling. So turning is the first part we did, face it, OD rough, and turn, center, drill, and bore it. And there comes your C-axis. So that's going to be where we can do our milling, and we can use our live tooling which is going to be your axial and your radial. Okay, so there comes my C-axis right here. So anything you do on the face is called your face contour, cutting outside. Like if you guys remember from your 173 Mastercam 2D class, cutting outside is your contour. So there comes my face contour right here, and the picture itself indicates that anything you're going to cut outside is going to be your face contour on the face on the part. It's called face contour. So I'll go ahead and do face contour, and now from here on, all the parameters you guys are going to see is going to be just like you would do it on the milling machine, guys. Look at this. We do face contour or contour. It's going to be, you're going to call the chain, and you're going to select this chain like you used to do on the mill. Here I select my chain, and the chain is sitting at Z minus whatever is my depth there, 130 plus 249, which is going to be 389. So my chain is sitting at Z minus 389, not at Z0. So I pick that, hit end of the chain, hit OK. And look at this here, your tool. You're going to pick the same tool like we used to do that. And I'm going to pick a regular 1/2 inch end mill to mill this. So we are just basically we're milling this part like we do it on the mill. So I'll go to my select tool, library tool, and 1/2 inch flat end mill is right there. We can just pick that, hit OK. That's my 1/2 inch flat end mill. Cut parameters just like mill, guys, just like mill. I'm telling you over and over again. My cutter compensation are going in this direction. If you look at here, the cutter compensation in my tool is going in this direction. So I'll keep up my cutter compensation to the left. It's a climb milling again. So make sure you say compensation is to the left. Start to leave on the walls means any material. If you want to leave on the walls, you can put that also, but I don't want to leave anything on the walls. Here comes my depth cut, how deep you want to cut each pass in. I'm going to leave this off right now, but I'll definitely go lead in and lead out. Means just like mill. I'm telling you over and over again, your tool is going to come with a tangent lead in, it's going to cut around the part, and it's going to lead out. So I'll say my length is going to be 50% of tool diameter, which is 250. My arc is going to be 50% of the tool diameter. That's fine. And same thing I'll do with the lead out exit, so I can go ahead and have this the same numbers. Multiple passes, we'll come back and talk this in a little bit. So going to linking parameters, just like mill, guys. This top of the part is this here, your Z0. This is my top of the part where we started, Z0. Here my depth, I select this, my depth is in incremental is going to be 0 because I select that already. This contour is sitting as Z minus 389. If it's sitting at Z0 and you select that, then your depth here is going to be minus 389. Not right now. Right now in incremental, this depth is 0. Top of the start is going to be 0 in absolute, which is right here. Feed plane, you can say in incremental 100,000 above that, that's fine. Or you can say absolute incremental is fine also. Retractable clearance 250,000, you can say that clearance is going to be 250,000 in absolute. Hit OK. There is your tool path. Look at this. It's going to come in with an arc in as a lead in, go around the part. Cutter compensation is to the left. If you look from the top view like this, look at this, just behaving like a mill, guys, acting like a milling machine. There we go. I'll go ahead and select all. and run all the toolpath and verify, and you see it. Face OD rough turn, and look at this how it's milling it. Rewind. Drill. Rough finish. And there comes my C-axis face contour. And if you see, it's doing only one pass here. We can do multiple passes. We can do rough and finish. Okay, so let's do rough, because it's taking a lot of material over here. Your tool can break, so you can control your multiple passes, just like mill. I'm telling you. Here we go. There comes my multiple passes. I want to do one rough or two rough. Spacing is, let's say, about 100,000. Then I want to do one finish. From the finish pass, I want to remove about 25,000. So two rough, one finish. There you go. Watch here. There we go. We have one and two rough and one finish pass right here. One rough, second rough, and third is finish pass. I'll go ahead and verify that. Just that tool right there. First rough, look at this. Just roughing it out. Second rough. And a finish pass. There we are. Same thing with the depth. You can control the depth. Let's say you're cutting 389 hole. You want to go half of that. You can control that too. Watch here. Under parameters. Depth cut. I don't want to go, let's say, more than 150,000. Maximum rough step, 150,000. It's going to go equal amount. Watch here. It's going to go first depth, rough it. It's going to go three passes, equal amount. Finish it, second depth. And finish it. There's a finish path, and there's going to be another depth finish. There we go. There's your finish pass. There we go. So you can control the depth also. Again, I'm telling you guys, if you look from the top view like this, we are just cutting like a milling machine. Just like a milling machine. And like I said, if you see all these parameters are like a mill machine. And that's what we studied in your 2D class. I want to go to depth cut. So if you look, the depth cut depends on how much deep did we cut. If you look at your blueprint, we are cutting 389. That's thickness. So you want to go two passes. I can go 200,000 each time. I'll say, hey, my maximum depth is not going to be 200,000, so it's going to go two passes equal amount. Okay, there you go. And I want to finish pass at the final depth, so I'm going to change that. So multiple passes. We're going to say multiple passes, order of finish, machine finish passes after roughing all contour. Machine finish spring pass, we don't need that. That's good. So machine finish passes after roughing all contours. There we go. Second rough. It's going to go first rough at Z minus 389. Second rough. And there comes my finish pass. And we can say finish pass at a final depth also. Where is that? Machine finish passes at final depth. Where is that? Depth cut, keep tool down. It should be over here. Multiple passes back. Finish pass, not at all depth. Finish passes at a final depth. So it's going to be just finish pass on final depth. There you go. Run it. So you're going to see two different Z depth and finish pass. So first rough, second rough, and then second depth. First rough, second rough, and then it's going to be one finish pass at the final depth. Another rough and one finish pass at the final depth. There we go. Perfect. That's what we need. All right. Okay, so we're going to do the same thing, face contour at this our star right here. So I can just go and hide that toolpath toggle, and let's go face contour again. If you want, we can do face contour. No, I don't want to keep it. I can just go ahead, right click, keep and hold and drag it and say copy after. I want to copy another, exactly same thing. All I'm going to do here, I'm going to change my geometry. I'm going to use the same tool. I'm going to change my geometry. So this geometry was for your outside rectangle or square. I'll say right click. I say rechain all. Now I'm going to pick this guy over here. And chain, hit OK. Hit OK. So this is my new chain here. I'm just copying, saving my time. So here I want to do two rough, one finish. That's fine. If you want to do that, or you want to change depth of cut here, I just do only one depth. I don't change depth of cut. We don't need it. Linking parameter is good. My depth is going to be 0. Top of the stock is going to be 0 in absolute. Feet per 100,000. That's good. Let's do it. Hit OK. Hit OK. Regenerate, and let's see how that works. There we go. First rough. Weed is not cutting here, should be fine. And then we have finish pass. You know, we have to just run this toolpath and this toolpath. Sorry, this and this, and verify it. Okay, and run it again. The star, first rough. Another rough. And there should be one more finish pass, I guess. There we go. That's your finish pass. Perfect. Look at that. All right. Okay, now we have to drill those holes. We can center drill and we can drill those holes. So here comes my face drill. If you look at here, you have a cross drill. When you do cross drill and C-axis drill, cross drill is going to be on the diameter. We're going to talk about these in different projects. But there is drill on the face, which is going to be a face drill. Cross contour is going to be cross contour on the, if we're going to have a keyway we want to, or cut any slot on the diameter, that's where we're going to be our cross contour and C-axis contour. So we'll talk this on the later projects. So let's go and say face drill. I want to face drill, and we're going to pick up those. If you have a circle, you can pick the center, because remember we turn those circles off. If you want to do that, you want to leave this on. We are still selecting the center of the circles, or you can just turn these off and we can just pick up this your points. So I'm going to select this 1, 2, 3, 4, 5, 6, 7, 8, and that's it. Pick those 8 points, hit OK. Here comes my tool. Filter. We can pick just the center drill. Wait a minute, right there. That's my center drill. None. Pick center drill. Excuse me. 1/8, number 1 or number 2, doesn't matter. We can pick those. Excuse me. Cut parameters. Drill and contour board. No drill is going to be a G81. Linking parameters. So if you remember, these are at Z0. So now here we got to go in absolute, and we have to tell what's going to be my depth from the face in absolute. So I want to go 150,000, or let's say minus 150,000. That's my depth, 150,000 in absolute. Top of the stock is 0. I want to retract 100,000 in absolute, and my clearance is 250 in absolute. Right now I'm doing in absolute. I'm controlling my depth over here. I did not control the depth for the contour because my contour has been drawn at Z minus 389 or Z minus 130 here. But the holes are drawn at Z0. So from Z0 in absolute, how deep I want to cut, that's 150,000. Hit OK. Hit OK. If you look at there, the tool from the front view, you look at that, the depth is controlled from the top going into the part Z minus 150,000. So let's go ahead and face and verify this. Look at that. That's your face tool. There we are. I can go ahead and copy and pick a different drill. I can do that also, or we can just go and say face drill again, and you can select, you can say go to your right plane, so we can see that. Pick this center point, that point, that point, that point, that point, this, and center point or that doesn't matter. They're all same. Hit OK. And my tool is going to be my drill. And what size the drill is? 184. And say none. Where are my drills? Okay, dokie, let's go ahead and select this 94,000.
Hey, sir, one question.
Yes.
Is the C-axis drill rotating the spindle in doing it, or is the drill
The drill
working
is
towards the position?
drill is rotating. The spindle is constant.
Oh,
Spindle
okay.
only index to that degree. I'll just show you the program.
All right.
Spindle is going to index. Your live tooling is turning on at 2000 whatever RPM, and it's going to drill that. It's controlled
Okay.
with your x-axis and c-axis. Yeah.
All right.
The spindle is constant.
Okay.
Main spindle is constant. Your live tooling is turned on.
All right. Thank you, sir.
Mm-hmm.
So, if we were to make the spindle rotate, what would that be? Something else, like would that be a different, like?
Okay, with the c-axis, your spindle with c-axis, your spindle turns into c-axis,
Okay.
and it syncs with x and your c-axis.
Okay.
I'll just explain to you in a bit. Just give me 1 second.
Thank you, sir.
So we're gonna have a drill here, and cut parameters, drill counter bore. You want to use G83, you can do that, or G81. So here's gonna be my depth. My depth, if you look at the total depth, is from 130 plus 259, 389. I can go 389 plus, we can compensate the tip. So we can say here Z minus, or we can say compensate minus 0.389. You want to compensate the tip here. The diameter is 193, and standard included 180 degrees. It's going to compensate 58,000 right here. So 389, or I can just even it out to minus 0.400 or 450. Not a big deal. And hit OK. There is my drilled holes. I'm going to run this entire part. Face it. Go to rough, finish, drill, spot drill, and bore it, finish. And here comes my face contour, another face contour, center drill, and your drill. There we go. All right. So now I'm going to show you just the tool path for face contour and C-axis drill. We're going to just post this to tool path. I want to show you the combination that we are just posting the tool path for this contour here for the star and the face drill. So you're going to see the way the tool path is going to come. It's going to be, look at this. It's a combination of your X and C axis. Look at this, how you see axis is turning, your spindle. Each block is 101.92, 102.692. That's degrees. So it turned into such a small increment degrees that becomes a straight line with C and X axis, which cuts this part right here. So look at this tool path over here, guys. This is just for this star outside. It's a combination of your X and C axis. The spindle turns on here. This is your live tooling, the one I showed you in the video earlier. That's your live tooling. The movement, tool movement, is X and C axis. Look at this, all this C axis. That C axis is your spindle.
Oh, okay. All right.
That is your C axis, is your spindle. And it controls the feed rate, where it's going to go at an arc or spindle speed. It's going to change. It's going to control the feed rate by itself every step. So this is, look at this here, 21.916, 23.6. Look at the increment. It's not even 1 degree each time. So combination of X and C axis is going to create that shape of your part. And again, you can only do that on the machine, lathe machine, which has a C axis capability. Not every machine has that. We run this part, the same part we run in our 186, and that class I'm going to teach next semester. We run this part in our advanced lathe class, which is 186. And those lathe, we have 3 lathes in that. For that class, we have a C-axis on those lathes.
That one's available next semester, right, Paul?
Yes, but you have to take 176 is a prerequisite, which is regular lathe class. So you have to take that to get into that 186.
That was with Mr. Rios, right?
Mr. Rios on Saturday, yes.
All right, we already took that. Just want to make
If you
sure.
already took that, then you're good to go.
All right, thank you, sir.
Then you can take that one. So the reason what I'm saying that whatever you have done here, you can see that in your real world when we're going to get into that class. That's how you're going to set it up, how you're going to set up your tool, and how you're going to do the face, OD rough, OD finish, drill, bore, and how you can do the face contour. So we have to do that attachment. We have to put the attachment, which is your live tooling, on the machine. And when we are done, we can take those attachment off. So this is the program we use that and to machine this part in 186 class. Okay, this is just for that, not for the square, just for this flower right here. And I want to show you the drill. Gentleman earlier asked that question. So the drill is going to be, look at that. The drill is going to index at C0. This is not correct. This is not correct. It should come. No, that's okay. Start at the C0, then it's okay. No, here we go. Whole number. Oh, this is going to be whole number 1 here. X and Y location, which was, this machine has a Y axis, X and Y location, and this one here is going to be X and Y location. Another hole, so another hole, and that's the whole number. So we have 1, 2, 3, 4, 5, 6, 7, and 8 holes right here. So here just is controlling your X and Y location from the center, and it's going G81Z minus 150D. So I'm just posting the only tool path for just those 2 tools, so you guys can see it, how that C-axis works.
Thank you, sir.
Mm-hmm. Okie dokie. Okay, so I'll just go ahead and pause this recording, otherwise it's going to be too long.
Recording stopped.
Okay, any other questions, gentlemen? So let's go ahead and review this. This is what you guys have to do. Going to level 1, we're going to start with this part right here. Select all, turn the tool path off. There we go. So stock setup, I'm going to go ahead and shade and monitoring, turn that off. So this is based on your blueprint, that what is the shape of the part is going to be, that how you're going to create that. So you got to start with a major diameter right here. So this diameter, like I said, is total is 1.475. I went like 1 inch, 2.1 inch in diameter, which is your 1 inch and 50,000 radius. That's how I drawn this part right here. The depth, I went a little bit more than that, and we turn this, and then this is based on your hole, what is the size of the hole is, which is 648. So I have drawn that 324, and we drill and bore that. So this is your regular tool path on the lathe, turning outside and drilling and ID bore inside. So that's done. So once this is done, then you're going to just go ahead and create your C-axis stuff. So you go and change that level and do that in level, different level, and turn that off, and you're going to do your drawing in construction plane right. Now here I have done this toolpath at, I move my drawing at the Z level, whatever I see here in geometry. The holes are, I did it on the Z0, then I moved my star at Z minus 130,000, then move my rectangular or square at Z minus 289, which you see this right here. Now the next project we're going to do next week, we're going to have everything at Z0, or we can move it back just like that. So we can, if you want to do this here, so we can do that also at Z0, but here, just as an example, I'm going to go ahead. So we already have this, so I'll go to File, Open. This is the project. If you say we have saved, don't save it. We don't have to save that. No, don't save it. That's okay. So look at this here. This part, everything is at Z0. So here, when we do the toolpath for the first one, I'll just show you. You don't have to do it. I'm going to say Lathe default, and I haven't done the stock setup. I'll just do face contour, and the face contour, if I'm going to pick this geometry here, hit OK, hit OK. Now under cut parameters and linking parameters, my depth here, guys, that's where my depth in absolute, I have to say my depth of that contour, which is 259 plus 130 is 389. So here I have to say my depth is Z minus 0.389. And the rest everything is same. I can hit OK, but okay, a cutter comp is not right. We have to go to cutter comp to the left. I can tell by right here. Look at that. Cutter comp to the left. Hit OK. Hit OK. So now we picked this geometry drawn this geometry at Z0. Function. Go ahead. We have drawn this geometry at Z0, but controlling the depth in my parameters. You can do that also. You can draw everything at Z0 and control the depth in the toolpath. Last time my geometry was over here, so what we did last time we just transform, hold the shift key. I moved that geometry Z minus 0.389. I moved my geometry back there. Look at that. That geometry is sitting right there. Z minus. That's okay. But here, when you do the toolpath, if you look at, I'm going to regenerate that. So now, on this one here, my depth is 389 because I picked my geometry was over here. Now, if I'll go ahead and do my toolpath, turning my face contour, and I pick this guy here, and hit OK, hit OK. So my geometry here, my depth is going to be in incremental, and this depth is going to be 0 because my geometry is at 389, guys. If you run this, hit OK, you're going to see the same result. But here in this parameter, I have done my part is at 389, so depth in incremental is 0. But the last one we did it, my depth is 389 because my geometry was at Z0. So you have both options. You can draw your geometry at Z0 and then follow the depth, looking at your blueprint that what's your depth is going to be for each, or you can draw your geometry at Z minus at that depth. Then in that case, your depth is going to be incremental, is going to be 0 because you already selected that geometry at that Z minus. So that's the only difference. It's totally up to you which way you want to go. But here, did it like the way we did it. You go to Z minus, move your geometry back at that certain depth, and create that program. Any other questions, guys, before I let you go? All right. Okay, so I'm going to just go ahead and stop the recording here. Somebody had a question. Can you make a list of project order that